What do you think about when you hear the term machine learning? Many of you are likely thinking about robots. Maybe it's robots that help us, that do our chores for us, or maybe it's robots that destroy us. Or maybe some of you thought about self-driving cars, or voice-activated virtual assistants, or computers that can beat humans at games like chess, Go, or Jeopardy. Or maybe you thought about chatbots that can now write essays just as well as humans. Or about recommender systems that know you so well that they can present you with exactly what you want to buy or watch next. Or maybe some of you are just now realizing, as I put up more and more examples, that machine learning is not something from a sci-fi future. The age of machine learning is now. And though we haven't created robot butlers or robot overlords yet, what we are creating is a world in which more and more decisions are being made not by humans, but by algorithms. And these decisions made by machine learning are directly affecting you, and they're affecting society. For example, machine learning is already being used in healthcare, helping to diagnose diseases and determine what types of treatments and medications you will get. Machine learning is already influencing how you shop via highly personalized recommendations, for example. Machine learning is already determining what information you have access to. Social media feeds and search engine results are determined by machine learning algorithms. What comes to the top of your feed or your search page can differ drastically with just an algorithm tweak. The information that machine learning algorithms decide to present us with fundamentally changes the way we view and think about the world. So it's critical that as we continue to move further into this algorithmic future, that we consider the impacts these automated decisions are having on us, the humans. My name is Angie Beasley, and I teach machine learning here at the University of Texas. When I was a computer science student, the idea that a computer could learn, that it could automatically improve or adjust its output as it got more information without changing the code, fascinated me. So I went to graduate school to learn how to do it. After grad school, I spent over a decade working on projects for the US Navy, including submarine sonar systems and unmanned underwater vehicles. So for a very long time, I had this very narrow focus on this one specific use of machine learning. And quite honestly, I never really thought about all the other things that machine learning was being used for, until I started teaching. When I became a professor, I wanted to give my students real examples beyond the sonar world of how machine learning was being used. So I started looking for examples. And I found a lot of really great examples of machine learning being used to do interesting and wonderful things. But I also found some really troubling ones. The way machine learning works is by finding patterns in data, often patterns that are too complex for humans to recognize. And once it finds these patterns, we can use that to make a prediction about the future based on the patterns we've seen in the past. So let me give an example. Say we have data on thousands of cancer patients, and which treatments work best for each person to eradicate their cancer. The machine learning algorithm would learn from this data by identifying patterns in which treatments work best in which scenarios, even if there are potentially thousands of factors to consider. Then when a new patient comes in, based on the characteristics of their cancer and their body, the algorithm can make a prediction about which treatment is likely to work best for this specific person based on what it has seen to work well in similar situations in the past. And this is truly amazing. This is one very real way in which machine learning is revolutionizing our future for the better. But let's change the scenario just slightly. Now, instead of using machine learning to predict cancer treatments, let's use it to predict who will default on a loan. It's the same thing, based on the characteristics of a person, and based on the patterns we've seen in the past of people with similar characteristics, the algorithm can make a prediction about how likely it thinks someone is to default on a loan. So these two scenarios are similar, but they have a very subtle difference, and that is the feedback loop. The thing that defines machine learning is that it can adjust its decisions over time as it acquires new data. Patterns can change, and what makes machine learning so powerful is that it can learn these changes and automatically adjust its output accordingly. So in the cancer treatment scenario, if a particular treatment starts to become less effective over time, we can feed those results back into our data set, and our algorithm will automatically learn to stop recommending treatments that are no longer working. But what about the loan approval scenario? If our algorithm predicts that someone is likely to default on a loan, then they will not be given a loan, and there's no new data point to put back in the data set about whether or not they've paid off a loan. Then the next person who comes in with similar characteristics is also denied a loan. And again, there's no new data point to put back in the data set. So the people that get characterized as likely to default on a loan will just continue to not be given loans, and there is no way for that pattern to ever change or update. The feedback loop is broken, and because of it, a whole category of people gets stuck under the prediction that they will default on a loan. In order for machine learning to work properly, it needs a feedback loop that can tell it whether its prediction was right or not, so that it can learn to correct itself and adjust to changing patterns over time. So you might say, well, how about we give them a loan with a higher interest rate? And oftentimes we do, making it harder for them to pay off the loan and more likely for them to default, biasing the algorithm towards its own prediction and keeping it stuck in the same pattern. Yep, it thinks to itself, people with these characteristics do default, and here's another data point to prove that. Machine learning models with these broken or self-reinforcing feedback loops cannot learn to correct their mistakes, nor can they adjust to changing patterns over time. And these broken or self-reinforcing feedback loops are exacerbating inequalities in society, as certain groups of people are more likely than others to be classified into the stuck prediction. Yet they're being used everywhere. Some colleges and universities are using machine learning to decide who to accept or not. If you have the characteristics of students who have succeeded at this institution in the past, then you get accepted. And if you don't, you don't. Machine learning is being used in job hiring at corporations. If you follow the pattern of previous successful employees, you get hired. Otherwise, you don't. It is being used in healthcare and health insurance. If they predict that you are likely to cost them a lot of money in future healthcare expenses, then they will not cover you. And in criminal justice, if the algorithm predicts that a prisoner is likely to reoffend, then they are not let out on parole. In addition to this, there's another issue with many of these machine learning models, and that is a lack of transparency. Too often, we do not know what inputs are being fed into the model. What exactly is being used to make the decision? So this is a true story. There was an online lender that trained a machine learning model to predict loan defaults. And their algorithm learned that typing your name in all capital letters on your loan application correlated to being more likely to default on your loan. And they used this model to approve and deny loans. Now, in statistics, they taught us that correlation does not equal causation. And we need to remember that things can correlate by chance. And that if we try enough different inputs, we will be able to find something that correlates by random chance. This world of machine learning and big data is enabling us to use more and more pieces of information as input. We can collect and use things like, did you have caps lock on? Did you submit your application from a computer or from a mobile device? Was your application submitted at 1 o'clock in the afternoon or at 2 o'clock in the morning? And these types of irrelevant inputs are being used to approve or deny a person's chance at buying a home or going to college or getting a job. We need transparency. We need to know what is going into these algorithms. Are the inputs they're using even reasonable to use in predicting what they're trying to predict? Or are they just hunting for random chance correlations? I learned about these uses of machine learning as I was looking for examples to give my students. And the more I learned, the more uneasy and eventually horrified I became at how machine learning is being used in ways that perpetuate unfairness, bias, and inequity. Just a few semesters into my teaching career, something that I had been so excited to get the chance to do, I had an existential crisis. I realized that this technology, when used in the wrong scenario, is causing great harm to both individuals and society. And I worried that I was contributing to that by teaching students how to do it. I considered switching the class I taught, or even quitting teaching. But I knew that even if I were to quit teaching machine learning, though it might ease my conscience a bit, the problem would still persist. So what I decided to do instead was to teach about it. When I learned machine learning in graduate school, I was taught how to do it, but we never talked about when it should or shouldn't be used, and that needs to change. So I started incorporating these discussions into my class so that my students would not just learn how to do machine learning, but learn when to use it and when not to, so that they would learn not just to think about the technology, but to think about the humans on the other end of it. How to use these algorithms responsibly and ethically needs to become a part of all machine learning education. And this is an important piece of the pie. The computer scientists who are implementing and creating these algorithms certainly hold a large amount of responsibility over how this technology gets used and the impacts it has on society. But this is not just a computer science problem. Think about all the places where machine learning is being used to make decisions. Human resources, advertising, lending, education, criminal justice, finance, business, economics, healthcare, insurance, and more. It's impossible to list them all. This affects everyone. This affects you. If you work somewhere where machine learning is being used, and especially if you are a decision maker, a leader, somewhere where machine learning is being used, I urge you to think carefully about how your use of machine learning is affecting people. Do you have a broken or self-reinforcing feedback loop, and who is being harmed by that? Are you using irrelevant inputs, like how one capitalizes their name to make life-altering decisions for people? Is your model transparent to those who are being affected by it, or are you hiding the input variables from them, and why? It is easy to become wrapped up in the buzz of machine learning, the incredible things that this technology can do, the profit that you want to make from it. But we need to take a step back and start from a foundation of ethics. And remember that just because we can do something doesn't mean we should. And for all of us, public awareness matters. We all need to be able to think critically about how machine learning is being used. When is it helpful and when is it harmful? Is this helping to create a future that you want to live in? And we need to express our disapproval when it is not. But we also just can't rely on self-regulation. We need official regulations. We need algorithm audits, similar to how we audit restaurants with health inspections or corporations' financial statements. We need audits that check these algorithms, that look at their inputs, ensure that they are working correctly, and determine if they are causing bias or harm. So look, machine learning is not all bad. We can use it for so many useful things that do not have these problems. We just need to consider when and where to use it. Machine learning is being used to do great things: treating and curing diseases, combating climate change, enhancing accessibility and increasing inclusiveness, addressing world hunger for a growing global population, identifying and eliminating disinformation and hatred, and so much more. The same algorithms that can be used to judge us unfairly and increase social inequities can also be used to increase social impact and make a difference for good. So which will we use it for? That decision is up to us. Thank you.